Can You Believe Hurricanes by Sandra Markle. Table of contents. Can you believe these houses were destroyed by the sun? These houses were blown apart by a hurricane, one of Earth's fiercest storms. When the sun's energy heats up one part of the ocean more than the area around it, a hurricane can begin to form. This book will let you investigate how that heat energy powers up a hurricane. You'll also learn why some hurricanes strike land and see the terrible damage some of these storms cause. Along the way, you'll discover lots of amazing facts about hurricanes. Some may even seem unbelievable. Like people, hurricanes have a life cycle. They are born, grow stronger, weaken, and finally die. So where in the oceans do you think hurricanes begin? A, in the tropics, B, near the poles, or C, at the equator? Turn the page and start exploring to find out. Can you believe hurricanes start in the tropics? The tropics are the areas on the map that are color-coded in red. The water in these areas receives the strongest blast of the sun's energy, but sometimes local winds or currents cause some parts of these usually warm waters to heat up more than others. The process that gives birth to a hurricane starts when a spot in the ocean heats to at least 80 degrees Fahrenheit or 26 degrees Celsius, and air starts to rise above this warm water. As the warm air rises, cool air replaces it. This moving air creates wind. The faster the warm air soars, the stronger the wind. Try it yourself. Watch how the process of warm air rising can start a hurricane. 1. Slip the mouth of a balloon over the neck of an empty soft drink bottle. 2. Set the bottle in a pan of hot tap water. Ask your parents for help so you don't burn yourself on the hot pan. How does it work? Air, like everything around you, is made up of tiny particles called molecules. When air is cold, the molecules move slowly and pack close together. When air warms up, the molecules speed up, bump into one another, and spread apart. That makes the air take up more space than it did before, so the air rises out of the bottle. You can see this happening because the rising air inflates the balloon. This is the same process that takes place in the tropics. Like air, water is made up of molecules. As the rising hot air sweeps over the water, it warms some of the water molecules. These speed up and are knocked loose into the air. This process, called evaporation, adds water vapor, which is water in the form of a gas, to the air. When the rising air is far away from the ocean's warmth, it cools down again. The water vapor cools too. As the water molecules slow down, they collect on tiny particles of sea salt or dust. The vapor changes from a gas to tiny water droplets. This process, called condensation, creates clouds. It also releases heat energy. This energy warms the air again, making it soar upward even further. So you see the warm air rising, and then it condenses, and it comes down as rain. A thunderstorm forms when warm, moist air rapidly rises high enough to cool, forming clouds and rain. If there is enough warm, moist air rising, a cluster of thunderstorms may form. Then, if winds force the thunderstorms to move together, the storms merge into one storm system. When the winds in this system blow steadily at 75 miles or 119 kilometers per hour, this storm is called a hurricane. What shape do you think a hurricane takes? A, funnel, B, pinwheel, or C, bucket? Can you believe a hurricane spins like a pinwheel? Here's the eye, and then the eye wall. Look at this satellite image of Hurricane Floyd. You can see the pinwheel cloud pattern created by spiraling winds. The clear center is the eye, where warm, dry air is surging downward. This moving air pushes out on the thunderstorms, shoving the closest ones tightly together. This forms a thick wall of clouds, the eye wall, where warm, moist air is soaring upward. The eye wall is where the storm's energy and its winds are strongest. What makes hurricanes start to spin? A, the sun, B, Earth, or C, the stars? Can you believe Earth's turning makes hurricanes start to spin? You probably know that Earth turns around and around. The force of this spinning is called the Coriolis effect. It starts the hurricane winds turning. Then the spinning winds sweep along the storm's band of clouds. Try it yourself. 1. Mark a dot at the center of the paper plate and an X on the plate's rim. 2. Have a partner slowly turn the plate to the right as you draw a line between the dot and the X. If the plate was held still, the line you would draw would be straight. Likewise, if Earth didn't rotate, air in a hurricane would flow directly from the outer edge in toward the storm's center, just as turning your plate makes your line curve. The spinning Earth makes air start to circle around the storm's center. Did you know hurricanes never form at the equator, the imaginary line stretching around the middle of Earth? The Coriolis effect is too weak at the equator to make storm systems start to spin. Can you believe some hurricanes grow to be much bigger than others? Look how much bigger Hurricane Floyd was than Hurricane Andrew. Hurricane Floyd, Hurricane Andrew. Hurricane Floyd 1999, Hurricane Andrew 1992. Did you know the word hurricane is only used when these superstorms are in the Atlantic or West Pacific Oceans? In the East Pacific and Indian Oceans, they're called typhoons. Scientists call all of these storms tropical cyclones. These maps show that Hurricane Floyd and Hurricane Andrew struck the United States in about the same place. Since it was bigger, Floyd caused damage over a much larger area than Andrew. The size of a hurricane depends on the amount of heat energy making the air and the water heat up and evaporate. The more heat energy there is, the bigger the hurricane gets. What makes a hurricane move toward land? A, waves, B, strong winds, or C, other clouds. Can you believe strong winds can push a hurricane onto land? A hurricane in the air is like these leaves in the river. See the ripples in the water? The currents creating these ripples move the leaves downstream. The layers of air surrounding Earth have currents too, ones with enough force to steer a hurricane. Because hot air rises and cool air sinks, Earth's air rises at the equator and sinks at the poles. Once wind starts moving, the Coriolis effect changes the wind's direction, so winds in the northern hemisphere push storms from west to east. In the southern hemisphere, the winds blow storms from east to west. Hurricanes may travel long distances before they run into land. Satellites with cameras can show the size and shape of these storms, but forecasters must know how strong the hurricanes will be when it strikes land. They also need to know when the hurricane will strike. Did you know there is a hurricane season? It's summer through autumn, then seawater heats up most. When seawater heats up most. How do weather forecasters figure out where hurricanes are heading and what conditions are like inside the storm? A, they use powerful telescopes. B, they shoot laser beams into the storm. Or C, they send people out to fly into the storm. Can you believe some people hunt hurricanes? Hurricane hunters from Keesler Air Force Base in Biloxi, Mississippi, fly into these fierce storms. You can't hear the wind over the plane's engine, but you can feel it. Passing through the bands of thunderstorms is as super bumpy as driving fast over speed bumps. It's very dark inside the hurricane, too, and raining so hard it sounds like tons of gravel is being thrown at the plane. Sometimes there's so much water streaming down the windows, it looks like we're in a submarine, says Major Valerie Hendry, weather officer for hurricane hunters. The hurricane hunter's plane is a flying lab, measuring the storm around it. There are sensors mounted on the outside of the plane. These sensors measure the weather conditions 8 times a second. The strongest winds are likely to be below the plane near Earth's surface. So several times during a mission, the hurricane hunters drop a special tube with a parachute out of the plane. Packed with weather sensors, this tube reports on the air temperature, wind speed, and amount of water vapor in the air all the way to the surface of the ocean. Here you can see Hurricane Floyd striking land in 1999. Weather forecasters use satellite photos and data from the hurricane hunters to make computer models. These models show where a hurricane is likely to travel based on the past, followed by past hurricanes in the same area. If a hurricane is likely to strike land, people need to be warned.